Picking up where we left off at, again, I said because this is a larger number. Some people may not know the highest perfect square that's in 75. So let's try the prime factorization method. With 75, this breaks down to 3 times 25, and 25 breaks down to 5 times 5. So the prime factorization is 3 times 5 times 5. So we put our two square roots here. Under this square root, we know we would, well, actually, we could just do the one square root. Let me do it like that. Since we're doing the prime factorization, we would write down 3, 5, and also 5. Now, t squared, we could write that as t times t. And w cubed, we could write as w times w times w. Now remember, all this is under the radical. So remember, it takes 2 to pull out 1. So we know we have a 5 out here. We have 2 t's here. We'll pull out 1 t. We have 2 w's here. We'll pull out a w. Now what's left under the radical is 3 and w. So our final answer is 5tw times the square root of 3w. Now, we scroll down here to E. Now we can multiply these values. 15 times 5 will give us, what's that, 75. And x to the 4th times x to the 9th to give us x to the 13th. Now we already did the prime factorization of 75, which we know was 3 and also 2 5s. Now we have x to the 13th. Now what I'm going to do here, I'm going to write us 13 x's. Let's see, that's 3, that's 6, 7, 8, 9, 10, 11, 12, 13. Okay, now it takes 2 to bring out 1, so we add 2 5s. We bring this x out. We have another set of x's. We have another set. Another. And finally, the last set of x's. And what we will have under the radical is 3x. So now we have 5 times x times x times x times x times x times x. And this will give us 5x to the 6th power times the square root of 3x. So that will be our final answer. Now listen, we have to come up with an easier method of doing this, because how many of you on the exam, if this would have been x to the 24th power or 29th power, you would want to write out 29 x's. So listen, all you have to do to find out how many x's that you will have here, especially if it's a 2 here, if the number is even, you would take the even number divided by the index. So let's say that would have been x to the 14. For some reason, the screen jumped a little bit, but we'll bring it back down here. Let's say under this radical, it was x to the 14. I'm telling you to take the index of this radical, which is 2, and divide that by the exponent. So 14 divided by 2 will give us x to the 7th. Now using this here, we had 13 x's. Now if you notice here, we ended up with x to the 6th, right? Now if we would have added in that 14th x, that would have took us to x to the 7th. So this actually works. Now what you would do is this here. We know whenever we divide an odd number by 2, we always have a remainder of 1. So if we took this 13 and divided by that index of 2, 13 divided by 2, we know will give us 6 with the remainder of 1. So whenever you have that remainder of 1, that means that it would be 1x under the radical. So x to the 13 divided by 2, we know that's 6.5. But we would just have the 6, which we have out here, and the remainder of 1 will be under your radical. Now, If you have any questions about that, you can come to class and I will give a deeper explanation of it. But let's move on to objective 3. It says we know that 3/5 times 3/5 is 9 over 25. So the square root of 9 over 25 is equal to square root of 9 over square root of 25, which is 3/5. So it says for a non-negative number a and b not equal to 0, square root of a over the square root of b is the same thing as square root of a over b, which both of them is under the radical. And here square root of a over b is the same as square root a over square root b. Now it says if a radical has a fraction as the radicand, we simplify the radical by writing it as an expression whose radicand is not a fraction. So now we have the square root of 16 over 81. So that would be the square root of 16 over the square root of 81. Square root of 16 is 4. Square root of 81 is 9. So it's 4/9. Now we come here to b. This will give us the square root of 7 over the square root of w squared. Now we know the square root of 7. We know that that is not a perfect square and it doesn't have a perfect square in it. So it will stay the square root of 7. The square root of w squared is just w. Now we come here to c. We have the square root of 12 over the square root of 25. So that would be square root 12 over square root 25. Now in previous lessons we did the square root of 12, which we know would give us the square root of 4 times the square root of 3. That's the highest perfect square, and 12 is 4. And the square root of 25 is 5. So this will end up being 2 times the square root of 3 all over 5. Now we go to d. Now we have the square root of 32 over the square root of 8x. Now watch this. Let's put this as a whole fraction here. So it'll be 32 x cubed all over 8x. Now 32 divided by 8 is what? You're correct, it's 4. X to the third divided by x is x squared. We actually just made this much easier. The square root of 4 is 2 and the square root of x squared is x. And that is the final answer to D. Now we scroll on down here. We go to section A3. It says objective 1, add and subtract radicals. We know that 8x plus 2x is 10x because we are adding like terms. Similarly, if two or more square roots have the same radicand, they are called like terms. For example, we had the square root of 6 plus the square root plus 3 square root of 6. Now if you notice, they have the same index and they also have the same radicand, which is 6, right? Now whenever you don't see a number in front of a radical or a square root, it's assumed to be a 1 there. So this would be 1 square root 6 plus 3 square root 6, which is 4 square root of 6. Now if you want to look at this a little differently, let's imagine that these square root of 6's were x's. If this was x plus 3x, wouldn't that equal 4x? Now we just said that we're going to represent the square root of 6 with x. So x plus 3x is 4x. The square root of 6 plus 3 square root of 6 is 4 square root of 6. It's the same concept. Now we come here to A. We have 17 square root 6 minus 2 square root 6. Both of the radicals had the same index and they had the same radicand. So 17 minus 2 is 15. And we bring down our square root 6. We're done with A. Now with B, if you notice, they had the same index for the radical, but under the radicals, they do not have the same radicand. So first, let's take out the highest perfect squares we can from these radicals. So this would be the square root of 25 times the square root of 2, that's for 50, plus 18 is the square root of 9 and the square root of 2. The square root of 25 is 5, square root 2, plus the square root of 9 is 3, square root 2. Now if you notice here, we have the same index now and the same radicand. So we can add them together. 5 square root 2 plus 3 square root 2 is 8 square root of 2. Now we scroll down here to C. Now we have to do C like we did B. We're going to take out the highest perfect square. And then 45, that's 9. And that will leave us 5x minus 2. And 20 we know is 4. And that will leave us the square root of 5x. So now we know the square root of 9 is 3. So it'd be 2 times 3 times the square root of 5x minus 2 times the square root of 4 is 2 times the square root of 5x. 2 times 3 is 6, square root of 5x. Minus 2 times 2 is 4, square root of 5x. Now, they have the same index and the same radicand. So we can subtract them. 6 square root 5x minus 4 square root 5x is 2 times the square root of 5x. And that is the final answer for that problem. Now we come over here to D. Now we do the same thing here. The only perfect square that we have with the square root of 2x squared is that x squared plus x. The highest perfect square in 18 is 9. So this will end up, we know the square root of x squared is x. So it'll be 5 times x times the square root of 2 plus x times square root of 9 is 3, square root 2. So this will give us 5x square root 2 plus 3x square root 2. Now, we have here the same index and the same radicand, so we can add them together. 5x square root 2 plus 3x square root 2 is 8x square root of 2. And that is the final answer. Now we move on to the next page. It says objective 2, multiply radical expressions with more than one term. Recall, when we multiply a binomial by a monomial, such as 5 times the parenthesis x minus 2, we use the distributive property. So we have 5 times x minus 2, which is 5 times x plus 5 times the negative 2. 5 times x is 5x. 5 times the negative 2 would give us minus 10. And that would be the final answer here. So we apply that to these radical problems. We would take this 7 and multiply it by what's inside the parentheses. So we have 7 times the square root of 6 plus 7 times the negative square root of 10. 7 times the square root of 6 is 7 square root of 6. 7 times the negative square root of 10 will give us minus 7 square root 10. Now, they do not have a common radicand. Their indexes are the same, but they do not have a common radicand. And that is the final answer, because they do not have any perfect squares you can pull out either. Now we come here to B. We would take 2 square root of 3 times both of these terms. So we had 2 square root of 3 times the square root of 12 plus 2 square root of 3 times the square root of 8. So 2 square root of 3 times the square root of 12 is 2 times the square root of 36. And then this is supposed to be a negative square root of 8. A positive 2 square root of 3 times a negative square root of 8 will give us a minus 2 square root of 24. Now, the square root of 36 is 6. So this would be 2 times 6 minus 2. The highest perfect square in 24 is 4. And we have 6 remaining. 2 times 6 is 12 minus 2. Square root of 4 is 2. Square root 6. Now let's revisit that. 2 times the square root of 36 gave us 2 times 6. The highest perfect square in 24 is 4. And we will have 6 left over. So 2 times the square root of 4 will give us 2 times 2. Now 2 times 6 gave us 12. Minus 2 times 2 is 4. Square root 6. And there's nothing more we could do with that problem. So that took care of B. Now we come down here to C. Now if you notice here, this refers back to the chapter that we did, the multiplication of a binomial times a binomial. So you know that we would take this first term and multiply by these two terms here, and the second term and multiply by these two terms. So we have 5 times 6 plus 5 times the square root of 2 plus the square root of 2 times 6 plus the square root of 2 times the square root of 2.